All right, let's begin some volume. So let's do pyramids. All right. In fact, a triangle pyramid. All right. We're saying that all of these are the same side length, and I want to find what is the volume of this pyramid. So imagine it's going to require a few values. Probably one of them will be this height right here. Let's call it h. Another one of them could be maybe this distance r. Yeah, and I think that's good. All right, let's get cracking. So the first step to making this an integral problem is you want to analyze it for its shape, because if you cut this in pieces, it's really just a bunch of triangles that are getting bigger. Yeah, check that out. So, an exact, whatever, you get the idea. It spreads outward. So we want to analyze it for each of these triangles so we can add them all up and get this finite pyramid. All right, that is the integral problem. So the cool thing is, honestly, you could define each of these triangles by one value alone. This r value. Look, it shows up in each one, and it decreases at what? It decreases at a linear rate. So if we studied just this r, we'd be happy. Now when we're actually going to be done with this, we'll probably want this value instead. But I prefer working with the r at the moment, so we're going to do that guy. Just so you can kind of think of it as kind of a circle getting smaller. Because we already did problems like that. Anyway, let's get started here. So, first step is let's define the volume of this, the area of this shape. So we can just take one radius and find it going all the way up. Good? Yeah. So we know it's linear. All right, this would be the graph of, there wouldn't be a down for some reason. But this is the cross sections right here, the r values. And this would be going along the side, which is kind of the h. Let's call it x for now. So we know this would be the r values, but before we even get there, what's the area of perfect little triangle here? So we have S, 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 that's a given. We're also given, if you make this cut, that more cuts would render. Each one of these is cutting 2 pi. We're going to work in radians in this one, I just decided. This would be 2 pi, the full circle, and it's split into 3 equal sections. So it's 2 pi thirds, or 2/3 pi. Alright, that's cool. So let's take one of, so how many of this triangle do we have? We have 3 of them. So if we find the area of that, we're good. So the area of that guy is, let's just draw it sideways, is this little height right here. Let's call it b. All right. It's going to be times, if we cut in half, it's s divided by 2. If we have this full thing, it's s. So the whole area of this guy is b times s divided by 2 because it's a triangle. We're making progress here. I say that a lot. Wow. Now let's change colors here. So let's just replace b and s because we know something. We know what this angle is. This whole angle is 2/3 pi. Now this is, both of these are half 2/3 pi, and half 2/3 pi is 1/3 pi. Easy as that. Oh, darn, you can't really see that. Let's write in blue. 1/3 pi. So, or pi over 3. That would probably be a better way to write it. Alright. So just using this fact alone, we already know that this side length right here is a length of r. That's to our benefit because we're assuming we know what r is. We're working on variables here. This might be a little difficult, but just keep in mind variables act just like numbers, except for sometimes you get problems. That's when limits come in. Whatever. Let's stay on topic. So we have r, and if we turn this sideways, you can easily see this would be the sine of that angle times r. So s divided by 2, right? This is s cut in half. S divided by 2 is equal to sine of pi over 3, except for it's multiplied by r because that is the hypotenuse here. Alright, so we found s divided by 2. So we're halfway done. We finished the s. Now let's find b. b is just, in this case, the cosine value. So cosine, let's write it up here. Cosine pi divided by 3. And then that's multiplied by r. And that's going to be equal to this b value. Alright, let's plug this in. So s divided by 2. Oh, we actually have s divided by 2, so we can just plug this whole thing in for s divided by 2. And then plug in the b. Alright, so now if you put it together, you get b is cosine pi over 3r, and this is sine pi over 3r. So we're going to have 2r's, so it's going to be an r squared. It's going to be a sine pi over 3. Then right after that, a cosine pi over 3. And that's just one of these areas, right? Yep. That checks out. That's just one of these areas. So now what we need to do is we need to have 3 of these areas. Check it out. We're done. Now, sine pi over 3 is a specific value. Know what it is? Well, it doesn't matter if you don't, because I'm going to say it anyway. So sine pi over 3, if you take a circle and you go pi over 3 up, that's a third of a half rotation. That's it's this. It's about that much. Well, it turns out that you can find what that value is pretty nicely because of equilateral triangles. If you split an equilateral triangles have same angles on all sides, and it has to add up to pi, or 180 degrees. So it's pi divided by 3 is each of these angles. And also, pi divided by 3 divided by 2, which is what this angle would be, is pi over 6. Yeah, pi over 3 divided by 2 is pi over 6. So this angle right here on equilateral triangle, if we cut in half, is pi over 6. And what do we know about this? If this side length is 1, and this side length is 1, if we cut in half, it's half right here. And then you can do some quick Pythagorean theorem to find out that this length right here, gosh, I should switch colors. That this length right here is square root 3 over 2, or it would also be 1 over square root 6, I believe. Either way, we're making progress. I keep saying that. We have that value here. So we know that cosine, so this is pi over 6, and this is pi over 3. So we just did this just so we could find this trigonometric ratio right here. So we know at pi over 3, which is what these are both saying, that the cosine value, it's the shorter one, is going to be half. Alright, just because if you double it, it makes an equilateral triangle. And then this guy will be square root 3 over 2. So plug it in. You get, this guy becomes, sine is square root 3 over 2. And cosine is half. Alright, half times square root 3 over 2 times 3 is a total area of 3 square roots of 3 divided by 2 times 2, which is 4 times r squared. Yay! We're done here. Except for that's just the area. Now we have to plug it into this graph. Let's just move on a page. Alright. So now we found an area based on this arbitrary length that we picked on the base. Alright. So now we know that the r gets smaller linearly. It goes from a length of this big R. Let's call it, this is kind of a different R. Let's call this a capital R because we made this a capital H. So this is the area of any regular triangle. So now we need an equation for that R value. So let's get going here. Let's remind ourselves what the equation for the area of equilateral triangle is based on this length of lowercase r. That is 3 square roots of 3 divided by 4 times r. Neato. Let's keep going here. And we also know that, let's make a graph of all these radii. And they're kind of radii. I think the actual word they'd use here is major radii, and then this would be minor radii. Though on a circle, that's the same thing, because any other change in cut, any other cut you make is always going to be the same length. So there isn't major and minor. But in here, there's a bigger one and a smaller one. So we pick the bigger one, we pick a graph. So we know it goes from 0, right? At the top of the pyramid, it has an r of 0. Goes to a big one of r. All right, so we know our graph should look like that. Let's call this r of x. So based on each x value, you know that this distance here is just a cross section of the side, right? It's the h, right? If you look at this, it's a whole height value. If you turn this sideways, you can see that graph it's a little slanted because of perspective. All right, so we have h. So at an x value of h, this becomes an r value of r, capital R. All right, I didn't need to mark that right angle thing, but I can. So let's create an equation for r of x. So r of plug in 0 should give me a value of 0, yes. And we also know that r plug in a value of h should give us r. So with that 2 pieces of information, this tells you that the intercept is 0. So you add 0 to your equation. That's nice, because that's nothing. And that other section, that r, tells us that if you plug in h, you want to multiply by r and divide by h. All right? Because when you plug in h into this, that cancels out to give you a value of r. And then last step, let's just generalize it into x. So this r of h is our factor, because if we plug in h into this, the h's cancel out and you get an r, which is exactly what we want. It's plus 0, and your h value goes where x is. So here's our formula, easy peasy. And here is our other formula. Let's make it r of x. And it's squared, my bad. All right, so it says square this value, and what we'll be doing is integrating from 0 to h. All right, this full height value. And we'll be adding every area, right? We're adding each of these areas from 0 to this value of h. So we have this r divided by h, and that's squared. And so it's 3 square roots of 3 divided by 4 times this r value divided by our h value. Both of those are squared. And then we also have an x squared. And of course, you have to integrate by dx, every small change along this curve. All right, we have to consider all of those. And this should give us the volume. So let's start working on it. So r squared, h squared, all of these guys are all constants. Even though they don't have a value right now, the r and h don't at least, we can still work with them. Nothing says we can't. This is kind of a problem I used to run into. I was like, but there's variables here, so I guess I have to quit. There's no way to get further. Yes, there is. There's easily a way to get further. Just move them out of the integral. So now we have 3 square roots of 3r squared divided by 4h squared. We have this 0 here. We have this h here. Now we have an x squared dx. That integral is the easiest thing in the world, or one of them. You just increase the power and divide by the power you increase it to. So we have 3 square roots of 3r squared. That's the known part. that's h squared. And now we have x to the 3 divided by 3, 0h. Alright, if you plug in 0 into this, nothing happens. And if you plug in h into this, you just h cubed. So it's h cubed minus 0, which is just h cubed divided by 3. I had to ignore the divided by 3 part. Alright, let's bring this outward. And this should be the volume. I forgot to write that. The volume of this pyramid. Let's draw a pyramid shape. And the triangle pyramid, whatever. Let's keep going. So plug in h3. So h3 divided by 3 multiplied by 3 square roots of 3. I already see that 3 cancels, but r squared divided by 4h squared. So the 3's cancel. This h to the 3 divided by h squared just gives us 1h. Times square root 3 divided by 4. Those 3's cancel out. Times r squared. And that's our formula for volume. Done and done. That couldn't have been any better, guys. Check that out. And you can double check this. And oftentimes you'll find the area written in terms of S. So just do some basic trigonometry to convert from R to S, and then you're done. In fact, let's just do that. Just get it over with. So one more page. Alright, here we go. So, sorry, I need to remember the formula. So the formula we just found is square root 3 over 4 times hr squared. Square root 3 over 4 times hr squared is the volume. Now we know that r, let's make this capital S. We know that r value is right here, and that s divided by 2, we already know what that value is right here. That's pi over 3, right? Sorry, that's really scrunched. So we know that sine pi over 3 will get us s divided by 2. So s divided by 2 is sine pi over 3, except for that is multiplied times r to scale it up. So s divided by 2 is a percentage of r. That's basically what that's saying. We're almost done here. We just want to solve for r, so we can replace r with s. So we already know that sine pi over 3. It's not pretty, but it's true. Square root 3 over 2. The r stays, and we have s divided by 2 over here. Hey, this is nice. The 2's can cancel out, so we get s equals square root 3r. And the last step, let's just multiply by square root 3 on both sides. Multiply this by square root 3, get square root 3s. This by square root 3, and you get 3 times r. So, close. And then divide by 3. You might be asking yourself, why didn't you just divide by square root 3? Well, technically this is the same thing. It's just, I want to get straight to the answer. So, I'm doing some easier steps. So we know that square root 3 divided by 3 times s is equal to r. So we can replace r with this value. And we have volume equals square root 3 divided by 4 h, and then r squared. Or this guy squared. So square root 3 times square root 3 is positive 3. 3 times 3 is 9. And s squared is s squared, literally. What cancels? This is the same as 1/3. So let's bring it out. So it's 1/3, 1/3. So you have square root 3 on top. 1/3, so 1/3 times 4 is 12. And we have h s squared. Hey, we converted. We're done with that guy. And is there any fixing we can do? Square root 3. Yep, I think this is good. So, yeah, this is what you do. And look this up online. Look up volume of triangle pyramid. Because this is what you should get. Unless I messed up somewhere. but I don't think I did. Alright, in the next few videos, we're gonna try and do this for any pyramid, which will include the cone, which is a pyramid with infinite sides on the bottom. So it'll be exciting. Thanks for watching.